Hello, stream 19. Let's see what the today command holds. Working to establish the ingestion library. We can update that one. What are we working on today? Edit com today. Today. I guess we're saying we're finishing up the elemental ingestion functions. I don't like the word finishing up. Implementing. I like that. Let's call it implementing. That's what I'm doing. Yeah, that's right. I'm implementing. So I have 1, 2, 3, 4 elemental ingestion functions. So string, decimal, integer, and bit. My objective this morning is to get rid of all the unwraps. So we have 1, 2, 3, 4, 5, 6, 7, 8 of them. Plus all the to-do. So that's 9, 10. So there are 10 things to get rid of. Some of them easier than others. So let's compare this to what I had in the, actually I don't need that bar. I can just do it this way. A decomposer. Like the bit elemental in the C code, what did it do and exactly? Oh, actually there are 2 errors we could have, right? Hold on. Bitstream read doesn't have an error. Wait. Yeah, what happens if we run out of buffer? Then we break. Huh. So it actually didn't handle running out of data the way I thought it did. So this is the condition where we run out of bits. It simply breaks, and then we would return 0. I wonder if that's because if we know the length, we actually set the limit accordingly. Let's check. So in should be, what is it, decompose? Maybe this is done. This has got to be done outside of the decompose, actually. Find show call hierarchy. Does this actually work? Oh, it does? Neat. Okay, yes. So we do set a limit based off of the length of the bitstream if it's from a file. Okay. And limit is different from bound, I think. Number of bits left in the innermost bounded region. Yeah, it's actually stored in the component itself. Storing the offset and limit in regards to the bit stream, okay? So I suppose that means inside decompose, there's a check against the limit. Wait, where is that done again? Elementals? No, I gotta search for it again. Okay, it was in the constructor. We set this up. Okay, that makes sense. So we use the same limit thing. This limit is set, can be set in one of two ways, right? Right, it can be set by the bound. Bounds minus offset, right? Okay. Or I guess that's up here, right? Or it's set by the, so it's initialized to be the whole bitstream length if it's from a file. It probably doesn't have a default. It has a default of 0. Okay. Okay, then I understand it. Let's try to do the same thing in the Rust. That means we don't actually need to do this option thing, right? We just return early whatever bits we have if we run out of bits, and just count on the user of the bitstream never to ask for more bits than we have. Okay, then I'm changing this back to U64. And this will just do a break. And then we just return the bits that we have. Yeah, we have to change the actual trait that we're implementing. That. Okay. Let's see what consequences that has. So we get rid of one of the unwraps right away. But here's where I think I need to do that check, right? Yeah, this check against the limit. So I should put it into the context is what I should do. Or actually, we're given the data component. We just put it in there. That's where it belongs anyway, right? Yeah, here we go. Yeah, I'm just trying to copy this comment. I got too many files. This is the number of bits left in the innermost bounded region containing this component, counting from the first bit which makes up the component. Okay, so limit, I guess, just like before. Makes sense. So should I force the limit to be set when we create a new component? I think that makes sense. Alphabetical sorting is nice. Limit. Okay. All right, we should be able to ask a bitstream its size, right? Yeah, we don't need to signal end a bitstream. Bitstream. Hey there, Get Off My Lawn and Red Rampage Crumpet and Robert Stefan. Elemental ingestion. I hope you're hungry for some bits, because we're ingesting them this morning or this afternoon. Yeah, I had a get length, a get offset, set offset, and read, and we needed to be able to implement clone. New bitstream offset operates on the same bitstream but has its own read write offset. Interesting. So that's a manual clone. Actually, no, I don't need to manually clone it, right? If I just implement clone on this, then we end up cloning an immutable reference and an offset, and then the offset is of owned value, so it will operate the same way. Should I do this derive clone now, or should I do it later? I think I should do it later. Let's put that in a comment, because we anticipate needing to clone it. Okay, let's just put in these methods that we know we're going to want, right? We're going to want to know the offset. Self. And we're going to want to set the offset. Mutable self. And we're going to want to know the length. Or should I be consistent and call it limit? Length, limit. Well, the traditional Rust one is len. I think we're just going to go with len. Okay, so that means I got to implement that for buffered bitstream. Implement missing members. Okay, that's easy. Self offset, right? This one's self.offset equals offset. And this one is self.input.length times 8, because it's length in bits. Is that not a U64? Oh, it's a size? Maybe it should be a U size. No, these are not sizes in memory. These are sizes in a bit stream. So this really should be a U64. But should that be a U size? Oh, I don't know. Okay, I'm undecided. I think it should be usize. But I don't have a strong reason why. Where we're going to run into a little bit of type friction is the bound is bounds in the syntax come from expressions. Expressions will give us an I64. Actually, there we have to check for negative anyway, so that's a good point to do a conversion to usize. Okay, so that if that's the only type friction point is bounds in the syntax, then we should be good to go. Okay, since we do specify that, we can simplify this to be self length and get rid of the times 8 there. Okay. Looking good, I think. So if it's not apparent from looking at this, and I know some of you are too shy to ask because I'm that sort of person, let me explain what we're looking at. So this is an interface, like an abstract interface, or a contract, or a pure virtual class. Sometimes also called a protocol. So this says that somewhere in our code we're going to need objects that can do these things, but we want to use dependency injection. In other words, the things in the program that use these bit streams don't want to know the actual implementation or the actual type of the bit stream. So we might want to do some operations that work either with a buffer in memory or bytes in a file or bytes that come from a network connection or maybe even synthetically generated bytes, like just computed by a function, right? So we separate the interface from the implementation and say that all of those potential objects would have the same interface. So like if you ask for bits from a file, it would do a read. If you ask for bits from a generator, it would calculate. If you ask for bits from a buffer, it would just copy, right? Setting an offset for a file would set the read pointer in the file. Setting an offset in a memory buffer would just record the offset so that the next time we do a read, it reads from that index in memory. Makes sense, right? And these are each function in the trait is like a pure virtual in C++. It's saying that every implementation of bitstream needs to have these functions. Hey, Brooke Zerker. How was your stream? You raid me a lot, and I don't have the opportunity to raid you back because by the time I need to go to work, you're gone. One of these days, though, we'll raid you. Hopefully, you had a great stream. I'm explaining what a trait is right now because I'm working with objects to implement traits, and I know there are going to be viewers who want to learn more about Rust, are interested, and they're like, "What the heck is a trait?" So I was just saying. A trait is an interface, protocol, abstraction, pure virtual class. They all mean the same thing. This is sort of like a contract saying that this category of different objects in code will all share these same characteristics and can be plugged in, so injected wherever they're needed. So dependency injection, right? Somewhere in the code is going to use a bitstream, but doesn't need to know what kind of bitstream. It can use any kind of bitstream as long as the bitstream object implements these functions. Hey there, Metame. We're experimenting with a way to use text to see a function result changing every save. Okay. So something on save triggers a change and use a test to see that. I think I understand it, but maybe not quite. Sounds interesting though. So hopefully this trait makes sense. Anything that claims to be a bit stream needs to be able to give us bits. When we ask for a certain number of bits, it gives us that. So there's sort of a baked in assumption here that n will not be less or not be greater than 64, because otherwise we wouldn't be able to fit it in the return type, right? So we should be able to ask a bitstream its current offset. So there's a pointer that goes with the bitstream that remembers where it is, so that when you ask for bits a second time, it doesn't give you the same bits. It gives you the next bits, right? Set offset, so that implies we can seek around in this bitstream. And length, which implies that the bitstream is not infinite. That actually, I wonder if I should make that an option to allow an infinite bitstream. I think I'm not going to do that right now. Right now it's going to be finite, and there'll be a finite length that we have to set. Really hard for you to explain right now, still figuring out exactly what you're doing, and if it's useful at all. Hey, that's fine. When we're experimenting, we don't have to actually explain what we're doing, right? It's just trying to figure things out. I like these emotes. Tawny Rust, Mod Program Rust, Brooksirk Ferris, and Cool. I don't have any of those. I just have like, actually I don't even have a crab. Here, I'll just wave back. There. Maybe I should make a Ferris version of myself. Last time these tracers confused, you didn't need to set pub on the functions. You set pub on the trait to make it visible outside of the library. And I need to do that because this is in the ingestion library, and so a user of the ingestion library might provide their own implementation for bitstream, so they need to be able to implement it. They need to be able to see it, therefore it needs to be public. But because the whole purpose of a trait is for all the things to know what their contract is, they're like all implicitly public, which is different from a concrete type. Usually they have to say which of their functions are public, which of theirs are private, right? I guess that's because usually, like in C++, you can have a pure virtual class is the same thing. It doesn't make much sense to make pure virtual methods that are private, because the user wouldn't be able to call them. At best, they're just saying that, hey, you need to have this function for you to call internally. It's like, why? I can just make that. I don't need to actually be constrained to do that. So yeah, it doesn't make much sense. So in Rust, you can't have that. Okay, so here's an implementation of the trait called buffered bitstream. It's called buffered bitstream because our bitstream is in a buffer. What's unique about, or what's interesting about this type, other than that it implements our trait, is that it has an associated lifetime. So why does it have an associated lifetime? Because it doesn't have its own copy of the buffer. It's borrowing someone else's buffer. Yes, although I think here it would just overflow. I wonder if I should have an assert though. It wouldn't hurt to have like an assert n is less than or equal to 64. If I could, I would pick a type for the return value here, or sorry, for n, I would pick a version of n that it's an integer that could be no larger than 64 and no smaller than 0. But we end up interoperating n with offset, and so it makes sense to have it be the same type as offset. And then, yeah, we do have to have this extra constraint maybe we assert in the code, right? Yeah, it would be cool, I think, to have like in the trait. Wouldn't it be cool if we could say where n is less than or equal to 64? Something like that. Or we could have a constraint on the values at runtime. then let the compiler deal with it. Kind of like a range checking. There's probably a clever way to do that with like static arrays. If you could somehow tie this to the index of a static array, and the compiler would know that it's like out of range if it's more than 64. So I need to organize my windows a little bit better. How about we just go and close some things we don't need? Don't need these. Don't need these. Probably need these. Don't need references. Don't need that anymore. Don't need statement, format. Definitely don't need that. I'm gonna sneeze. Hold on. Muted right before the sneeze. Okay. A quick recap of what I'm actually doing if you haven't seen my stream in the last couple weeks. So I'm working on a program called DataDisintegrator that had originally written in C and C++, actually. Parts are in C and parts are in C++. Its job is to pull apart the bytes of some file or stream and assign meaning to each one based on a description of the format written in a domain-specific language. So, for example, GIF file format. This is how I would describe it. I wrote this on stream based off of the GIF specification, which is really old. It's like from 1989. A GIF file structurally starts with the header, ends in the trailer, has some data blocks in the middle, has a logical screen, which is a description with maybe a global color table and all that. The screen descriptor has the width and height of the logical screen, or in other words, it's the size of the GIF. So given this, if we wanted to parse this GIF file, our program is going to take this description and kind of walk through it in order in alongside the actual bytes of the GIF file and say, oh yeah, because the format says the GIF starts with a header, and a header starts with a string called signature, which is 24 bits long, followed by another string whose version is 24, and then the logical screen is next, and that has a screen descriptor, and that has a little endian unsigned int 16, and little endian uint16 means we have an unsigned integer called LSB that's 8 bits, and an unsigned integer MSB that's 8 bits, and you shift that left 8 and add that. When we actually look at these bytes, we say, oh yeah, recognize those 3 bytes as a signature string. Next 3 is the version number, and then the next 2 bytes are 44 and 1. So that's the LSB, the MSB, and then shifted together, that's 300, if we look at it as a little endian. And that process repeats for the entire file until we basically get a huge data structure in memory that we can walk, and we can say like, well, where is the last data block begin? It begins at this offset in the file, and how long is it? It's this many bytes. And you could conceivably walk through this data structure wherever you want and locate anything you want. So you could pick out an individual image, you could then decode the image and show it on the screen, or you could just like print out how big the image is, both decompressed and compressed, right? Or maybe you just want to get overall file information, like the fact that it's 300 by 300, or that it has 61 frames in it. So other conceivable uses of the tool would be like protocol dissection, like what they have in Wireshark, where given a packet, which just really is just bytes that come across a physical link like Wi-Fi or Bluetooth or Ethernet, we can interpret the bytes by what they mean in terms of the protocol stack that's represented inside of it. So like we have a physical frame on the wire, which holds an Ethernet packet, which holds an ARP request, right? And if we knew the format of each protocol layer, we could parse the bytes using those format descriptions and get to where we can click on a byte and it would tell us what it means, right? So doing that kind of thing. I'm also, because it's fun for me, I'm taking the original version that I written here in C and C++ and kind of porting it to Rust, and also like adding abstractions in there to make things nice and separated using the single responsibility principle and dependency injection to and using test-driven development to make everything easy to test at a unit level, make the interfaces nice and clean, and you're doing all the good design things, right? So there are 3 parts of the program. There's the lexer that takes this description of a format and breaks it down into its constituent parts, which would be the tokens. So like these 3 characters, that's an identifier, and there's punctuation, another identifier. Here's a reserved word, here's another reserved word. So they show up here. That's called the lexer. That stream of tokens here goes into the second stage, which is called the parser. So that turns the token stream into an abstract syntax tree. The abstract syntax tree looks, hold on, run that. It looks a lot like the original code, only it's all in memory. So GIF is a format, and these are called parts. So like they represent parts of a GIF file. So there's a header part, logical screen part, and then there's a local variable declaration, and then we have a loop. So it pretty much mirrors the original program, but it's now in a data structure in memory that we can walk through, and we don't have to worry about how we encoded numbers because they're reduced to an actual int in memory. And showing you the actual types in Rust is pretty easy. Here is this overall GIF is a format, so it has a name. It has maybe has some arguments and has statements. Each of these is a statement. So a statement can be a part specification like that. It could be an ignore, which is basically parse it, but don't assign it a name, just skip it, right? It could be a conditional, like this if statement. It could be a loop, different kinds of loops. You can see like we're just retaining the in-memory representation of that original program. So part statement has its arguments. If it had a bound, like header has a bound of 24 bits, all that stuff, right? So then we're going to take that because it's logically a data structure that's like a tree, because it's a composite structure. A format can have statements. A statement could be a loop. A loop has its own statements, and it kind of branches out that way. We call it an abstract syntax tree. That goes into the third thing, and that's what I'm working on today. So we're using that abstract syntax tree to break down input data into its elements. So that's what I was showing in this one. When we read in these actual bytes and assign meaning to them, we're populating another data tree that mirrors the abstract syntax tree and contains the actual values we read from the file. So at the foundational level, we have to have certain built-in formats. So I have a very small set. There's string, there's unsigned integer, there's bit, and then there's decimal. Mr. Balrog, hey, what do you call a restaurant that only sells bean dishes? A gas station. Nothing quite like mixing a dad joke with a bodily function joke. That's like dad squared joke. Okay, what's the change they made? Oh, made it say C++. So we're ingesting those those bits, and determining what they mean, right? So that's what I'm doing today. So an elemental bit is taking a bit stream, asking for 1 bit, and then taking the value of that bit 0, 0, 1, and just stuffing it into an integer. Just like in C, if the integer is 0, it means the bit is off or it's false if we're thinking about truth, true or false. If it's a 1, then it's on or true. And yeah, going back to this bitstream class, this buffered bitstream class, I should say, it's implementing a trait called bitstream, right, that we're going to use in the ingestion, because the most popular one being bits, where we're saying, hey, we want a certain number of bits from the bitstream. Buffered bitstream implements the interface of the trait in terms of a buffer that someone else owns, which is why we have a reference and we have to track the lifetime. Whenever you take a borrow like this and stuff into a structure, it infects the structure's lifetime as well. So the lifetime of the structure, you specify like that. It says that to the compiler, make sure that anytime a buffered bitstream is constructed, that it only stays valid for up to, but not longer than, the how long this is borrowed. Otherwise, it's a borrow checker error and the program won't compile. So the lifetime of the overall structure has to be the smallest of all the lifetimes of the values inside. Now, one might ask, what's the lifetime of this offset? Well, offset is just a type, the offset is just a value. It's not a reference. Values are always owned by the structure that they're in. So something that's owned intrinsically lasts as long as the thing it's in. So we don't have to say its lifetime. It's effectively the same lifetime, this input span, right? The one we have to do is we have to say how long all references last, because that's how we prevent stuff from being, pointers from being used longer than they're going to be valid for. Hopefully that makes sense. We construct a new one by giving a pointer to someone else's buffer. We're just going to hold on to it and start out at the beginning of the bitstream, right? The hard part here is when someone asks for bits, we have to make sure that they didn't ask for more than 64, because our type restricts us, so we can't give more than 64 bits at a time. And basically, this is going to accumulate the output bits into this variable and return it at the end. And along the way, we're just going to keep trying to collect bits until we don't need any more. We're going to break out early if our offset hits the length of our, basically hit the end of our buffer. And then here we're figuring out what byte we're in and then what bit in that byte that we're in. And then calculating how many bits are left in that byte, how many bits we want to take out of that byte. And then when we take the byte out, what mask are we going to apply to only select the bits we want. And then shift is how many bits we need to shift that the original byte to select the bits, and basically put the bits in the low order bits so that we can add it to our output. Then we shift up what bits we had collected before, and we add in those new bits as low order bits. And then we count that we read those bits out, we advance our offset, and then we loop back. Try to assign names to these so that if you read through this, you kind of get the idea of what they mean. All the other methods of bitstream are really trivial, because if someone asks where we are in the bitstream, well, we have a variable for that, right? And if they say jump or seek to another place in the bitstream, we say, okay, we'll just remember we're going to read from that next time. Our length is always the length of our slice or input byte buffer times 8, because everything is counted in bits. This, if we were asked to give bytes at a time, this would be a lot easier, because our data type is byte, right? We wouldn't have to divide the byte into bits using this kind of math. So what can we do with this bitstream? We can use it whenever there is in the format, there's an elemental part of the data that's 1 bit. We can ask the bitstream for 1 bit, like I was saying before. This unwrap isn't necessary anymore, but I'm keeping that there because we need to protect for when, like, we say we need to parse a bit, but we don't have any bits left. In the original code, we did it this way. We used a limit, and we said if the limit's 0, then it's an error. We've exceeded the boundary of our input, and consider it an error. So I think I want to do it the same way. We're going to have an error flag in the component. And originally this is like a log message. I think that makes sense because these parsers aren't supposed to do anything more than mark an error. Actually, we might want to have an error callback and like not only log the error, but also like give the error string to a callback so that if this was in a user interface, we might take that string and do like show it in red text right next to the field, maybe. I think we'll just start out with doing log though. And that reminds me for the we're going to have a program, right, called ingest, a thin shell to test it. I didn't make that yet, but when I do, we're going to want it to use a logger so that we can print log messages. And if we're going to make log messages, then I need to, in the ingestion library, say we're going to use the standard log crate. So let's do that now. And I don't know what version we're on. I'm going to go to libs.rs and type in log and see what version it's up to. We're up to 0.4. One day it'll get to 1.0. But today is not that day. Okay, so let's do that. Roughly what we were doing in C here. If data.limit equals 0, then we're going to say data.error equals true, and we're going to log an error. Well, we do that with the error macro, right? So the C code just printed exceeded boundary. Let's do the same thing. Exceeded boundary. We have to say that that comes from the log crate. We have to give error storage. And I think I would like to copy over the comment that I had. Wrap. This flag indicates whether or not there was an error in determining the value for this component. Yeah, so the idea is that if you had a GUI like Wireshark, and you see how it's like sort of intended to be like a tree, so like address resolution protocol, you can click on the tick mark and it shows like child nodes, and maybe those could also have child nodes. That if there is some error deep in the protocol stack, it would highlight every level from there up in red. So it might mark the frame red. Actually, no, the other way around. It would mark, let's say protocol size was wrong. It might say protocol size like 10 gajillion, and it would just highlight that in red. And then it would also highlight the address resolution protocol in red, just in case if you had that folded and you didn't see the protocol size, that you'd know that there's some error in there. So the error flag, in this case, would translate to highlighted in red. So it would highlight ARP and it would highlight protocol size, but it wouldn't highlight frame, Ethernet, hardware size, or the other fields that aren't error. So that's my intent here. The flag gets mapped in a user interface to like showing it in red or some other way of showing that there's a problem with that, and then it would infect its parent. So it would highlight in red all the way up. And so these errors are caught at the lowest level of ingestion. So it's when it's an elemental bit and we run out of bits. Now it's like there should be a bit here, but we ran out of data. So mark it in red. And we're also going to log an error message with that. So now I don't need that. And I'm going to want to have this similar kind of thing for like an unsigned integer. So first, we need to know how many bits it's bounded by. And then here it would be if the bound is greater than our data limit. it's exceeded the boundary, right? I think just like in the C++ version, we only parse it in an else block. I should do the same thing here, right? And same thing for this. The bound is an I64. All right, we need to turn the bound. We need to do this check, right? So if bound is less than 0, what do we do in the C code? That's interesting. So I didn't quite do what I expected. For one, where are we? I guess I parsed the bound separately, but this limit equals 0. Shouldn't that be limit is greater than bound? Or limit is less than, the component's limit is less than the bound. Oh, I baked it into component limit. That's what I did. Okay. I think I just did this to keep it simple. We exceed the boundary if limit gets reduced to 0. If the limit's greater than, it's like we can't parse that many bits. Otherwise, we use the limit when we do the read. Okay, so where would we compute the limit? Show all references. Here we go. The limit is the bound minus the current offset, and the bound is computed how? Here we go. Oh, this is a special kind of bounds thing. I think this is what I want. There's an offset and there's a limit, but again, where is the limit calculated? Huh. This can't be that recursive. I must be skipping the part that is important. Oh, is it elsewhere? Or like one of these? That's for the overall file, right? Data size and the limit are equal to the bitstream's length. Yeah, that's the overall file. But somewhere we do this calculation. Where is it? I'll find it. I will find it. It's got to be here somewhere. Is it here? Ah, here we go. Okay, so there's a default limit. That's like basically the boundary of the current context, like how many bits we have left minus where we are. Okay, that's why. So yeah, our context needs to have a bound. That's the default limit. And then if you set a bound, that's this. So it would parse it, evaluate it as an integer. Oh, here we go. Less than 0, it's a negative bound error. If it's greater than the context boundary, then it's a inner bound surpasses outer bound. And I do this outside of the elemental. Okay, that makes sense. So we do negative checks and we do blowing up the boundary in before we get to the elemental here. So by the time we get here, it won't. So we're not really. That means that we shouldn't be evaluating the expression here. This should already be just a usize. And then we don't do this check. Well, I should do the 0 check, just like the C code does, right? Because for some elementals, a 0 would be fine, but for a bit, it's not fine. A string, it's fine, right? It just becomes an empty string. But for a bit, and for integer that's not fine. Yeah, it should be if the data's limit, if the, right, it's set. Okay, that's right. We don't even need to set a bound because it should be set in the data's limit. So it's 0, it's exceeded boundary. If it's data limit's greater than 64, then it won't fit. What did I come up with for that? It's like, why come up with something if you've already done it? Too many bits. That's what we came up with. Too many bits. So then its bits is data limit. And that's going to be is that going to be a size? I think it's already going to be a size. Yeah, because we're going to make them all U sizes. So that's data limit. U size. Okay. So that means we don't need to unwrap it. There's still this thing where there's an issue where if it's exactly 64 bits, the sign gets lost. I wonder if that means for now I should make that a 3. I think I will, because we can't represent an unsigned 64-bit yet. And this will I'll mark as with a to-do. Here we're limit to 63, not 64, because we use I64, not U64, to hold the parsed value. Should that be a to-do or should that be a fix me? Well, the to-do really is support full 64-bit unsigned integers. And then this is an explanation about why. Actually, I'd rather that be another line and then separately wrap that. Okay. Okay, so this we don't do here. This should be done elsewhere. So let's pull that out and paste it where it should go. Yeah, it should be in this part statement, right? Yeah, the part. I guess we'll put it here. Well, what happened? Cut. I guess I must have done a delete instead of a cut. Paste. Okay. The bound is in the statement. I thought it was in the part statement. Yeah, bound, option expression. All right, here's where we're going to handle one of the unwraps, right? The original code was if there is no bound, we use the bound, the bound in the context limit, the limit in the context minus the current offset, right? So if actually I could do an unwrap or, can't I? Yeah, let's do statement bound as ref. Then we're going to want to map it because we have it's an expression if it reaches this point. And the way we're going to handle the expression is we're going to do a context evaluate expression. Okay, it returns a data value or an error. So it's going to map to a result. So we'll have an option result, which is fine, right? Yeah, because we can have an error that we couldn't coerce it to an integer. That's the other thing. This does value coercion. Like it'll do a string to integer conversion using this coerce. Which is a virtual function. So there's like a coerce for strings in here, for example, that will convert a string to an integer. Right, coerce to integer does a scan the string using an I64 pattern. Okay, so a couple things then, right? I think then what I want to do is evaluate expression can fail if it's actually how could a evaluate expression fail? Let's see. I'm curious now. How did I define that to be a failure? Oh, I guess if we couldn't promote, yeah, couldn't promote them to be comparable if it's compare. Okay, so there are just ways in which we can fail. And in original C code, I didn't actually have I didn't propagate an error message. I just logged it. Okay. In this, we have this error, which we don't have variants for yet, but conceivably we will. Okay, so then, yeah. Just trying to do more than one thing at once is always hard. And that's what I'm trying to do now because I thought I could. Because we have to, the statement bound is an expression if it's something. So we also don't want to move it out. So the asref gets a reference. It starts out as a reference to an option. So we want an option to option of a reference. That's what this does. And then we map the option to a reference to be like, if it is a reference to an expression, then we're going to evaluate it in our current context. That can return an error or it returns a data value. Right, so then I want to do a map again from data value to value. That needs to be coerced to integer. So yeah, we should have a way to coerce it. Coerce. And that could return, I guess it's not map then, it's and then, right? Because and then can return another kind of error. Yeah, so the way and then works is if it's an error, it just doesn't do anything. But if it's not an error, then it runs this function which can itself return an error. So there's two ways we can get an error. Either we couldn't evaluate the expression for some reason, or we couldn't coerce it to the right type. So I have to be able to express the type here. I guess we're gonna have to have another enum to represent that type, right? The type of a value. Right, we have data value. but that has attached data. I want a version of this where it's just the discriminator part. And so I think that means we're going to have another type called data value type, where we remove the associated thing. Type integer. So that can return an error. So the result of this is either a data value, which is an integer, or it actually, let's have coerced, if it succeeds, actually just strip the integer out and return it. That makes it easier because then the output of this should be integer, and then we can do unwrap or, and then here the default integer is going to be context.limit, which doesn't exist yet, minus bitstream offset, right? Or context offset. Self dot, we're inside of ingestion, right? It would be in the C code, did I have a context? Context offset? Hey there, 0xgsat. And hey there, Fricks on CSGO. Do you know every programming language? No, no one knows every programming language. I kind of lost my place in my own code here. Actually, it would be execute statement part, right? Yeah, this part. The default bound. Oh, the part has an offset. I forgot about that. So that would be part.offset. Well, it's set up here. So I should have set it up here. Dereference sets it? Huh. That's an odd way to do it. Okay, here's fundamentally what it does. It sets an offset if we have a bitstream in the context. Oh, there's a bitstream associated with the component. Okay. What would you say your top 3 languages? Rust, C++, and Swift, I guess. Well, I don't know. Maybe not Swift. Definitely Rust and C++ are in the top 3. Yeah, let's just keep it at Swift. Rust, C++, and Swift. Unwrap or, okay, so where am I? What do I have to deal with? What does the context have a bitstream in it? It does. So why don't I just use that? Context.bitstream.offset. Now, if we do take the default because of an error here, am I propagating that error or not? This should propagate the error. Okay. Well, that's not one. We do set an error on the part. Okay, so then I shouldn't write it like this. It's only if there was no bound. Okay, then it should be what I was trying to get at here was part.limit equals that. I was trying to be clever and like say, well, the part has to have a limit, so set it like that. But we need to have the side effect of setting the part's error here somewhere. And not only that, but we returned early with an error. Okay. Oh, right. Shoot. Then we have a nested result inside an option. So really I should handle the option first, right? And if there is an expression, then there could be an error. Okay. How about your bottom three? Bottom three languages. I guess they would have to be the ones that I don't know and that I never want to know. So, yeah, but I'm going to answer it anyway. Bottom three languages. I guess we can pick languages that I've known in the past, but I despise now, right? I guess that would be Perl and what's another horrible language? Most languages aren't horrible. I'll pick from two that I just have no desire ever to learn. I guess they would be the joke languages or the yeah. So that would be Brain F, and so we have Perl, we have Brain F, and then we have um I'm not gonna say one of those code obfuscation languages because I mean one of those coding golf languages because I actually might want to learn one of those. It's the code obfuscation languages I think are just terrible. So Brain F, Perl, and I need to pick a third language I never want to learn or wish I had never learned. That's really hard. How about Fortran? We'll just pick Fortran because nowadays we can all pile on Fortran because it's such an ancient language and they're just better things. There we go. So Perl, Fortran, and Brain F. You had a bad experience with Ruby, but that was in university where all you studied was C++, so it made no sense to you back then. That's fair. I wouldn't count that against Ruby though. I almost said COBOL. I almost said COBOL, but I figured that Fortran is even more dusty than COBOL. You main Perl? Well, I'm sorry, but yeah, Perl to me, Perl is just like sometimes I wonder if it was knowingly made so bizarrely. The fact that you had to put a symbol, like if you had a variable called foo, that this means something different from that, but with the same name, it's just to me just is evil. It's the obscure punctuation that changes the meaning of things. I really didn't like that. List context is where it's at. I don't know OCaml yet, but I've heard that it might be a fun thing to learn because things from OCaml are still relevant today in Go and Rust and other languages. Also Haskell, heard great things about Haskell being a fun language. So a language isn't really outdated until things like the fact that that a line is a comment if it has a certain character within the first 6 columns, and the only reason why was because the language was designed around card readers, we no longer use card readers, right? So that makes it outdated. Like something in the language that is either built around or constrained by some physical thing that existed in the world when we were using computers like 50 years ago. Like that means it's outdated. So at least the original Fortran for sure. I think Fortran got updates though, right? Lori Wall's now all into Raku. It's kind of funny. X Perl 6. I had a mentor who hated Larry Wall and he hated Perl, and maybe that rubbed off on me. But I just remember trying to use Perl, and even when I thought I was good at it, it was just still a nightmare. And my code was horrible, and yeah, it was just awful. YT is shilling you a language called UIUA? You mean like the YouTube algorithm thinks you like to learn about it, now it's giving you a whole bunch more videos on it? Larry was an author of Patch utility. Patch isn't so bad. Patch actually uses punctuation clearly and effectively. It's just how the punctuation is so bizarre in Perl. I can never get past it. Single, yeah. Perl is almost like a coding golf language in how obscure and yet compact you can make certain syntactic constructions. He recommends other languages to use. Okay, I'm trying to solve two things at once, which is never a good idea. It's that we could have an error and we could also just not have a bound at all. So if I don't have a, this is to unwrap the option. If we don't have a one, then do we do that? That's okay. If that's unwrapping the option, then well, let's get the type correct. Let's see what the type is. Limit. Separately from setting in the part, right? Type as a result, right? Okay, this makes sense to me. So if the option is nothing, then we get it from there. But then I actually need to put it into an okay, right? To make this work. It's okay if we don't have a bound, but if we got an error, we need to handle the error. So I guess that means else. Let okay limit else, right? And in this else is where hopefully I want to do part.error equals true. Actually, you know what I want to do is do a match. Match this, and if it's okay, we are assigning it to that. If it's an error, we're doing that and returning. So maybe that's the better way to do this. So take this out. We do a match. We do that, and then we do part.limit equals limit. Or we have an error. Which does this. And we're going to return early. I guess for now we're just logging the error, right? Or I guess we can just do the E. It accepts. It doesn't. You might be missing a string literal with. Okay. Yeah, we don't actually have anything in the error enum right now, right? It's just an empty. So and let's say that we already have logged it. Then we don't need it right now. Context doesn't have a limit yet, so we need to add that. Limit. You wonder if you could use transpose there? That's if you want to handle, like, if you want to handle the error first before you handle the value. So I could, well, I thought this would be easier. Oh, but you're right. Actually, you might be right, because then I wouldn't need this okay, right? If I transpose match And then inside here, I do limit unwrap or that. Okay, yeah, actually, I kind of like how you're thinking there. So this would be a transpose, because then I can move this into here. And then get rid of the OK there. Right? So all of that gives me a result. It's kind of hard to see because it doesn't show the output of transpose, but it started out as an option result. The transpose makes it a result option, and then we handle if it's an error or not. And if it's not an error, it's an option. And so if it's none, we need to get a default. That also lets me do like maybe we get a none from here at some point in the future. Okay, so we don't have a coerce yet. We need to add that for data value. Implement data value. Function coerce. I guess it's clonable but not copyable. I guess we're just borrowing self. And we need two data value type. And this gives me a result, right? Coerce, how did coerce work? Okay, it kind of worked like an option. We didn't return an error, but maybe I want to return an error. Okay, let's keep it like the C code. So that would be make it an option. Data value. Okay, so basically we're going to match self first. Okay, and then we can just keep these to-dos, right? And we can just handle one of them. So like a string S would be like a match to. String to string is identity. String to integer is let. I need to stop and look at chat because chat's going on something. Oh, just a programming language discussion. That's fine. I'm going to keep working. I hope you guys don't mind if I don't take part in the programming language discussion. Rust, of course, takes a lot of concepts from OCaml and Haskell explicitly. That's one of the reasons why I might look into OCaml and Haskell, because I like Rust so much. Maybe I'll like OCaml and Haskell for certain things. So fundamentally, I want to do a use64 parse, right? Well, it's going to be a s.parse, and then I need to handle the error. The way I wanted to handle an error was if basically if it's an error, right? I guess then it's a match. If it's an error, we don't really care about the error, but we are going to return none. And as a side effect, we want to print what this used to print, what the coercion code used to print. Oh, we did it outside of that. Okay, well, I can do the same thing. Unable to convert some value from some expression to some type. Okay. So that would mean I would I would have this return an error and a result, and then I would do a match out of that. So so then I do, it would just be parse then, which makes sense. Actually, then I would just use parse also, right? Actually, it's parse and then map value, or in this case, it would be like an I, but this other one would be an S, and this would be data value integer I. And this one would be data value decimal D. And this would be okay, always. And then here I would do match the match. Okay. Value goes to some value. Error, we're not using the error right now. Goes to none, but has a side effect. Heard that TypeScript is just a better JS solving lots of problems. No, Fricks. Who was it? I think it was it's either CM Griffin or Strager who said TypeScript is really the illusion of type safety in JavaScript, but there are many ways it could break. You have to remember that TypeScript doesn't add anything to the runtime. It just adds type annotations at so-called compile time. So once your code is running, TypeScript doesn't give you any benefit. It's just checking your code. It's kind of like a linter. That's my a transpile time. Okay, yeah. So I think of TypeScript as more of linting. Once it passes that lint or transpile stage and it's at runtime, it gives you absolutely no benefit over JS. So, because I'm comparing it to something like Rust, where the at runtime, well, actually, Rust is sort of the same way, right? At compile, types exist at compile time for Rust, but they don't really exist at runtime. So maybe my judgment of TypeScript is too harsh. Because Rust generates pure assembly code that has no types in it, right? I guess the difference would be between strongly typed and weakly typed languages. So TypeScript sort of makes it a strongly typed. Strong typed language is a type exists at compile time and not at runtime. Weakly typed type systems, it exists more at runtime because it's weakly typed because it passes the compilation stage, and it's at runtime that you have the consequences of things being different types, right? And like the runtime has to know about the types of things. Actually, that means JavaScript is a weakly typed language. JavaScript retains some information about the type, right? That if it's an object or a what is it? There's very few types, right? It's like object and or is everything an object? I don't remember JavaScript. What am I? I shouldn't talk about JavaScript. I don't know it. I'm just gonna copy what I had in this other place. I guess that's not where it was. Is it here? I think it was clicking there. I got there. Here we go. Because I already wrote this once. Why write it again, right? unable to coerce value self from expression. Hold on, what? Oh, that's at the expression level, not the data value level. Hold on. Here. We have an expression at this point. Oh, shoot. So it was in a wrapper for expressions I did this. So at this level, it's not an expression anymore. But wait. At this point, we've already turned it into a value. So we'll just get rid of the expression part type. 2. That means we'll have to implement debug for this one. What's that sound? Hold on a second. There's like a weird sound. I need to go check it out. And hello, Stripe Monkey. And it's something happening right next door. It's just a bunch of workers are moving things around. But they're so close to me that like it sounded like someone was like scraping something along the wall. That's your dog barking? No. Okay. What's wrong with this? They have incompatible types. I kind of don't get it. Why does it say that this is not compatible? Parse int. Oh, because they're different errors. I guess I gotta map the error. Yeah, okay, map error. I don't really care about the original error right now. To error. This is the problem with my enum, right? Where did I define this error type? I put it here for now. But error is so ambiguous, I think I actually need to call it something else. Let's call it ingestion error. Okay, now the dog's barking. But it's not your dog, it's my dog. So let me go see why she's barking. Okay. I don't know why the dog was barking, but while I was going to check, I remembered I forgot to put the trash cans out, so I needed to do that. Sorry about that. Let's move this to its own file. I don't know. Error.rs, I guess. And I guess we'll have to have one kind of error at least. Unless I do something like a struct for now. Then you can just make one, right? Yeah, that'll work. Why are no code actions available? Why can't I do a use crate? Oh, I know why. Because I forgot to do a mod at the crate level. Mod error. And why don't we just use a pub use? Because we want the errors to be exposed, right? Possibly. Error. Then I could just use in here. Here. Import crate. Okay. Then I have to do the same kind of mapping there. What's wrong with, how come, oh right, it can't be an S, it's got to be a data value string S. Data value string S. What? What? Oh. We're supposed to borrow to course it to another one, so I have to clone it. Or to owned, I guess. Just clone it? No, because yeah, to owned. Or to string. I don't know. I always think, should I use, is to string better than to owned? They're like the same thing, right? Import from log. You can't put self there? Data value doesn't implement display trait. Oh, shoot. We could though. What was it? Is it the is it token that implemented display trait? Or was it a debug trait? We implemented debug. In the AST, did I implement the display trait for expression, I guess? I did. I explained display for expression. So what did I do for literal? Okay, I just did that. Let's implement the display trait for a value, and I'll just copy what I did for the AST. So pull display or data value. And we do a match self. And so it's going to kind of, it's sort of going to follow this. So that goes there. That goes there. And that goes there. And I'm done. Cool. We have the display trait implemented. Coerce. There's still a problem with coerce. What is it? I don't know. It's got a little dot 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 private. Oh, public. Okay. What are these other errors? Error is none or false. What's limit? Oh, that should be a U size. We need the limit here. I guess the limit would be this right here, right? Actually, if we have a default limit, then I don't need this unwrap or do I? So we would just put this up here. So then it's only if it is sum. So it would be okay sum limit, right? And what do we do if it's okay none? I guess we do nothing. So this is probably better restructured some other way. Okay. Still, the chat is independent of what I'm doing. I guess that's okay. I won't be offended. The type doesn't match? Limit doesn't exist. Oh, that's because we did it there. Oh, that needs to be, wait. This is old code. We did it up here. Right? Yeah. So I delete this. Okay, yeah, and then we don't need this anymore because the limit is sort of baked into it. Okay, I need to fix this to remove the bound. Because we remove this. And that, okay, we still need to check to make sure bound mod 8. Did I ever actually check that though? That would be under S. I did. I have a truncated last octet and it is an error. I did that. So we want to do that here, I guess. So if bound mod, why don't I just copy the whole thing and port it over? That's if bound or data.limit so the limit is a number of bits. It's not a position, right? I have to remember that and not get limits confused with bound with yeah, I shouldn't use the word limit then. It should just be bound. Or I need to use consistent terms. So I'll fix that in a bit. So this becomes an error. And this is just a data dot error. And this would return early then, or do an else. Turn early is better, right? Okay, we don't need to unwrap that anymore because we already know that we're not going to go over because the limit should be set right. Right? Hold on. What did I do for this? Yeah. Yeah, that's already guaranteed. This I need to check to make sure we have exactly 8. Actually, I didn't check it. I guess they're just bits we don't use if it's less than 64. It's sort of lazy. So it would exceeded boundary is what we printed. Okay, fine. If data limit is less than 64, error exceeded boundary, return. We get the next 64 bits. So let me leave myself a to-do. Should we warn /error if limit greater than 64? I don't know. It would be unused bits that we're skipping, right? I'm actually not sure. I need to go back to the C code. I don't remember I don't remember if a bound just sets a line where if we go past it, it's an error, or if does it actually say that this data value will use all those bits, so the next value jumps past that. I don't remember. For string and for UI and for, well, bit definitely doesn't. So we should also have that. If the limit is greater than 1 here, right? Should we warn if the limit is greater than 1? I'm thinking the answer is no for these. So that means that the next field doesn't start immediately. It doesn't start after the limit. It starts immediately after the last bit we consume. A bound larger than the data seems like something should be warned about. Yeah, that's what I was thinking. But in the original C code, I didn't do that. So if you set a limit on a bit and it was greater than 1, it just happily just took 1 bit. It just read 1 bit, size is 1, we're done. I need to look and see, like, how does it set the offset for the next field? Let's look at it. So we jump to the current offset, which we set how? We get the offset from the bit stream. That's the initial offset. Oh, hold on. This is for a look ahead, so never mind. Where do we set the offset? Okay, it's set elsewhere. So probably when we are parsing, executing a part statement. Okay, yeah, here's where we do it. So we get the current offset. So that implies to me that it's wherever the bit stream was. So if we had a bound of 10 and we read 1 bit, and then followed by that there's another bit, it would be immediately after the first bit, even if the bound was 10. I might have a warning here, like if we don't use all our bits. I don't see it though. It's part, right? Unless it's for all statements, we do a check. I don't think so, right? There's lots of different statements. Yeah. So it would just be a part. Is there any warning if we don't use all the bits? Negative bound. Okay, there's an error if our bound, if we specify a bound and it's more bits than we have, it's an error. Here's the default one, right? Oh no, that's not the default one. Default one was set up here, right? Yeah, the default is all the remaining bits. If we set something, it can be lower, because if it's greater than yeah, then we will get an error. Okay. Arguments, then we do the decompose, and that's where we would actually use the bits. And then we do some diagnostics about what it turned into, do the L value thing. Yeah, it doesn't care. It doesn't care if we didn't use all the bits. And it lets the next field use the next bit. I think that's why I have a bounded region statement. I think there it's different. This statement bounds, right? There's where I probably put the warning. Let's see where I do that. So we set a bounds. Yeah, here it was. After we execute the statements in the bounds, if we have any leftover bits, we say we're skipping extra bits of a bounded region. Right. That's why that's the decision I had made 5 years ago. For a part bound, it's just an upper limit only. It doesn't imply that unused bits get skipped. If you want to skip unused bits, you make an explicit bounded region, and if you don't use them all, then it skips them. If you didn't use them all, by just jumping the bit stream, set read offset, it jumps past it. Short-term goal is feature parity, yes, and long-term goal is to improve the tool, yeah. So I think you're right. I think if you set a bound and you don't use all the bits, we should do maybe a warning saying that the bound is wrong or something. Because there's no reason to set a bound unless like you know the size, right? But then how would I express like a looser bound where it's like, don't go above this or it's an error, but you can go below? Maybe a different kind of bound. All right. Oh, just fix the warning, fix the errors that we have in the code right now. So what are we missing from context? A limit. Wouldn't that come from the data component? Okay, now I gotta look and see how that worked. That's decompose. Here. So that just goes in there. Okay, yeah. So we take its offset and add its limit. So the limit needs to have been set before. So I do have a difference between a boundary in the context and a limit to the component. The limit is the limit in the number of bits. I probably documented that, right? This is the number of bits left in the innermost bounded region containing this component, counting from the first bit. Okay. And boundary is different. Boundary is the offset of the bit after the last bit within the bounds for the statement group relative to the start of the bit stream. I'm glad I documented these things, by the way. So that means back here, I shouldn't have a context limit at all. And I need to document this. So it should be a context boundary. And let's document it. Because I'm getting myself into trouble calling it limit and not documenting it. Boundary. This is the offset of the bit after the last bit within the bounds for the current statement group relative to the start of the bitstream. While I'm at it, is there a comment for bitstream? I didn't actually put the bitstream in the context because I attached it to the component. So I need to look at the component. That's one change I'm making. Maybe it's not the best change, but yeah, we're putting it in the context, not the component right now. Actually, I think it does need to be in the component, and it needs to be shared like that implies. So why don't I just make that change now? That means we're going to be using a trait object rather than using a generic, right? For bitstream. That cleans up the type again. We don't have to be generic over, well, it doesn't clean it up. It trade-off, right? Instead of being generic over the type of the bitstream, now we're going to have to put the bitstream as a trait object. But I only did that because you couldn't have, I didn't use a template in the C++. I used a trait object explicitly. If I wanted to not use a trait object, we could still do an RC, right? We would just be generic. We would use the generic in there. And that works because it gets monomorphized. Okay, so then yeah. We're moving the bitstream then, but let's put the doc comment for it. This is the object that provides bits which make up the data of the component, but we're moving this now into data component here. Or was I trying to keep this sorted? Well, it's not sorted anymore. Let's sort it. Bitstream goes first. That means the data component has to be generic on the type of the bitstream, which makes sense. So rather than actually, it doesn't need to be a shared pointer because it intrinsically is a shared pointer. Oh no, wait a minute, it's mutable. Oh, is that why it was a trait object? Because it's mutable? I forget now. In the original code, what did I do with that bitstream? Let's find all references. I'm wondering if each component gets a cloned bitstream or not. Part bitstream. No, it's just shared with its parent. Wouldn't it make more sense to clone it? Because this thing had a clone. Had a clone. So that it has its own read-write offset. I made it fallible though. What? So where did I use this clone? Did I ever use it? I did. Not. I did not use it. I implemented it, but I never used it. Okay. Well, shoot. So that's a bad design. It's implemented everywhere. Huh. Oh, shoot. What am I going to do? If I do it as is, then it's a problem because I allowed shared access to a mutable object. Okay, so we can't do it as is because it's unsafe. It's intrinsically unsafe. So how should it be? I think it should be with cloned bitstream objects, or yeah, it should just be an owned object. It should be an owned object, not a reference. And they should be clonable, but we still use generics. So yeah, back here in data, it's not a lifetime anymore, but it is generic on B. And yeah, we have just a B. Okay. Actually, can I just say B here? Or we'll have a problem with that. I guess not. But the moment that I say that we have a bit stream, you know what I just thought of? We could build the limit into the bit stream. If all bit streams have a limit, why don't we just build it into that? Then it's unambiguous. It would be the subset of bits that the data component is traversed over. So that means that not only do I want to set offset, I want to set limit or set length on it. Okay, I'm happy with that. So there's no limit. Instead, there's a bit stream B, and we have a bit stream. No limit. Put these in order. No, I don't want a limit. Yeah, okay, so that comment still stands. It's still the object that provides the bits which make up the data from the component. It's just that should also imply to me when I read that it's only the bits. So let's say this is the object that provides the bits which make up the data for the component. The bits stream has only the bits for the object and not any other object outside of it. Okay, that's what I want to say. All right, and then I'm going to basically break everything. Okay, so the composite, yeah, that's where the B is used. So then I don't need this lifetime anymore, right? Because that lifetime is sort of actually, how is this going to work? If the buffered bit stream uses a lifetime, this context doesn't have it anymore, right? Because we're not borrowing the bit stream anymore. It's actually borrowed by the inner object. Will I be able to get away with this? I think I will, because this will have the lifetime that will have the lifetime attached to it. So that actually makes this a little bit cleaner. I don't actually have this lifetime anymore. What's wrong with this? I just need to import it. Okay. So this is a B again. Okay. Do I have to actually say bitstream there, or can I just leave it as a B? I can just leave it as a B. And do I need to say bitstream there? No. Cool. Let's see if I can get away with just deleting it from everywhere. Wait, then, hold on. Oh, right. This has like the parent bitstream, and this is the child bitstream. That's how it works. Somebody's boxing away and that the wrapper encapsulates the lifetimes for you. Yeah, yeah. I never thought of it that way, but that's exactly what we're doing. Right, here's where it gets interesting, right? Ingest. Maybe then if we already have the composite that we're making context for, we don't need this bitstream anymore. Because, yeah, it's not there. What was in the context then? Just the composite and the boundary, which we technically don't need anymore, right? Oh wait, no, that could be within a bounded, right? We could have an artificial limit on it because it's set during a bounded how did that work? Like in a bounded region, statement bounds, right? Where is it? Statement bounds. We get a bounds, and then that, oh, we just made this nested context. Okay, that's how it worked. So the context has a, why do we have a first statement in there? I don't know why. I don't think we need that. This should just be a recursive call to execute statements. But I see how this works. It would use the same composite, but with a different bounds. And that boundary, again, is relative to the start of the bit stream. Thing is, there's no bit stream in the context, so it's really the bit stream of the component being decomposed, right? Yeah, okay. Then we do have a boundary, and it's relative to that. So the boundary would default to so back even in the C code, the boundary should default. This should default to the limit, the offset plus limit. See if that's true. Well, that's in a bounded statement, but what's the default? Yeah, offset plus limit. But I'm changing that, right? So my bit streams are now always going to have a start with 0. That means I don't add offset to it. It's just limit, right? Yes, yes. It should just be the limit of the component, which should be the size of the bit stream for me. Okay. I don't want to get too confused by what I'm doing here. This is the offset of the bit after the last bit within the bounds. Relative, well, start of the bit stream, sure, because the bit stream has start of the bit stream is at 0. So it's just, yeah, okay, fine. Just saying the same thing over and over again. So when we ingest a component, the boundary is initialized to be the composites. Wait, what? Where is it? How come? Oh, it needs to be public. Composite.bitstream.length. Oh, this is where I have to say it is a bitstream, right? In order to have access to that. Yep. So I would have a problem if I didn't say bitstream there, because it'd be like, actually, it should be a problem, but I have other problems in the file, right? Let me fix the other problems. That should come back as an error later. What's the problem here with coerce? Expected result found an option. Hold on. this returns an option. Oh, I turned it into an option. And we've already, okay. So I'm doing a no, wait, what? Okay, then maybe I keep it as an error because we do that already. Okay. Then I can actually preserve the original errors here, right? Okay, so that's a result ingestion error. And then I don't do a match, do I? I just say let result equal that. And then I say if result dot is error, and then it's result. And that's only so that I only need one place where I print the error. And later maybe I print what the error is. Or I can actually say what the error is here. Like that. So then it's if let error equal result. It should have given me an error for that error because it's because I have other errors in the code though. I need to chase all these errors down first before, or else I'm going to get too far off track. Missing generics for, right, that needs a B. No, it's actually buffered bitstream. You can't see that? Missing lifetime specifier. Ah, yes. This actually, but I'm not sure we're gonna do it this way. Oh, this is for the test, right? Yeah, okay, so then this is fine. Bitstream. That was expected. Cool. But this is a problem. Why is that a problem? Two arguments. It needs the, all right, we're storing it in there. That's where it goes. Bits goes in there. Does that mean ingest doesn't need the bits? It doesn't. It's just a composite. There we go. I fixed it. But now I got 9 more errors. Okay. Right. These are all the places where we have to say it's a bit stream. That actually goes on the left-hand side, right? Or actually, can I do it this way? I can say where. I can do that instead, right? Oh no, it doesn't like that. Required by bound and data component. Ah. Okay, if you put the requirement out there, then the requirement has to go everywhere in all impls, I guess. Yeah, so this conveys that every implementation of data component has this constraint. If I removed this constraint there, then I would have to put it there. I'd have to put it on somewhere here, but it wouldn't be required there. It's only required when we get down to like, actually it wouldn't even be required here now. Maybe do I just leave that off? Yeah, like why does this care if it's a bit stream or not? It doesn't, right? Can I just leave that completely off? Yeah, okay. What actually cares that it is? Okay, error, we need to implement debug on our error. This thing. Gotta start thinking about wrapping this up so I can go to work. Hi everyone, Steely. It's your first time here? It is your first time here. Wow, you have a old account. Almost as old as mine, I think. How are you doing? I'm working on the guts of a data parser. So it can take any format and pulls apart the bytes of a file that follows a format, as long as you can describe the format in a domain-specific language that I came up with. Here's what the language looks like. This gets compiled down to an abstract syntax tree that we're walking through in order with the input data bit stream and producing a composite structure of like elements that we've identified are in the file. So for example, if we're looking at this example GIF file, it identifies that it begins with a signature as part of the header, and then it has a version number, and then it has, there's the width and height that are encoded in the file. And it's basically taking this structure and applying it to these bytes. That's what my tool does. And I'd written it in C up to a point, C and C++, and I'm porting it to Rust. Some of the terminology's changed. Some things didn't have official names in the original implementation. Now they do. Like I didn't have these abstraction layers, token and AST before. And my Lexer, I didn't bother giving it a name because it was just something that went into the formatting or the parser. But I've already done this. We're on stream 19, so the other 18 streams dealt with these. Now we're doing this. So we're using an abstract syntax tree to break down binary data. So the binary data is represented by an object that implements this trait. So one example implementation is a buffered bit stream. So it has a buffer in it. It has to like be able to extract bits from the buffer, which is the most complicated part. Mostly because we're storing it as bytes, and so but you can ask for a certain number of bits. So it has to be able to like break up a byte into bits and shift things around and all that stuff. Along with that buffer, it also remembers where it is. So it's got like a pointer, an offset, and it needs to remember how long it is. And I'm just trying to like, here, the ingest function is where we're trying to fill in this data component based off of the bit stream. So the data component remembers the bits that made it up. It remembers what its format is. And this keyed children and its value represent like what we parsed it as. So like if it's like the header will have two keyed children, the signature and the version. And the signature and the version will both have values, which would be those original strings, GIF and 89A, right? And the goal in the end is to make like a nice user interface, kind of like Wireshark does, where you can, if you click on an individual packet or an individual piece of a packet, it shows you the bytes, and you can click on bytes and it shows you what those bytes mean. And maybe even we can make it so that you can change things or like find bugs in files like corruption and fix them and do all kinds of other things. I'm mostly just doing this for fun though. Part of the fun is porting this to Rust. So this was it was in C, C++, porting it to Rust. Never did anything seriously in trying to learn C finally. That's cool. Don't have a use case for learning C. Or you don't have a use case for what I'm doing. So one use case for what I'm doing is making an data analysis tool like Wireshark. So there you go. I'm telling you what one use case might be. If I wanted to make my own version of Wireshark, I would basically take my tool and implement my bitstream trait in terms of a network interface. So you would ask this implementation of the bitstream, give me some bits, and it would say, okay, let me wait for the next packet. Okay, now I have a packet. Let me give you the bits from that packet. And then if I define the format to be a string of packets, and we could then analyze that, basically my data analysis, the formatting, what am I trying to say? The format description can have conditional logic in it. So if it came in as a packet, we would like read the first bits as like this frame, and then based on what's in that, using conditional logic and the formatting, we would say, okay, well, based off of what's in the first 60 bytes or certain number of bytes in the frame, we know it's an Ethernet version 2. And the next couple bytes in the Ethernet 2 would tell us it's an ARP packet, and then etc. Right? So I could make my own Wireshark by defining all the protocols that we know about, and then implementing my bitstream interface based off of a protocol like a network card packet sniffer. So if we implemented this trait and as a packet sniffer, and then wrote down what all the protocols mean and had a UI for it, we would have Wireshark. You get it? But I'm more like it. That would involve like actually making a network sniffer tool, which is hard, much more hard than just reading a file. So here we have a file. It's easy to take the bytes out. You just open the file and read, and now you have the bytes. So it's a lot easier. And also the GIF format's very easy to describe. We can do it in like about 161 lines of description. And so I'm just using this as an example to kind of like show off and also to test things. Okay. We have a lot of errors to deal with. Okay, so the component has a bit stream. The idea I had was that the bit streams were like imminently clonable, like cheaply clonable. And then the bit stream encodes the limit now. So I think what the way this would work then is it would be data.bitstream.length. Can I not call length on that? That's what I want to be able to call. If the length of the bitstream is 0, why can I not call that? Oh, because of this again. We have to say it's a bitstream. Now we can call length on it, right? Right, and then, so this is now data bitstream bits. Read the bit. Okay, so the same thing applies. Limit becomes bitstream length. And context bitstream becomes data bitstream. And this has to be a bitstream. And again, the limit becomes the bitstream's length. Okay, cool. We're making progress. These elemental functions are the built-ins. So if you saw my this, the like header and trailer and data are all declared elsewhere in the file, but like when you get to header, we have this S. So these are what I call elementals or built-in formats. So that's something we don't need to define. The tool already understands that an S is a string. You just need to tell it how many bits long the string is. Right? So it's a length. It's a string where we know the length. We don't need to look for a null character. If we wanted to, we could build up a format for a null terminated string where we did this kind of a look ahead syntax to say like look ahead, the next byte is it a 0, and then stop. Otherwise, add more to the bound, and then we would get to where, okay, now we know where the null is. Now we define this with the S. The string is that many bytes long. You think it's good for you to learn C and learn C sharp after? So, Steely, that would be like asking, do you think it's good for me to learn German and then French after? It depends. What are you going to use C for? And then what are you going to use C sharp for? Neither is a prerequisite for the other. Learning one would help you learn the other. So it's the same thing as if I were to say, is it good for me to learn German and learn French after? I mean, like, maybe, because once you know German, some words in French are similar to the ones in German. Maybe it's more like French and Italian, right? Is it good for me to learn French and then learn Italian after? Sure, because once you learn French, you'll know some words in Italian come from French, and so on. Unless you only need French. Yeah, if you only need C, then there's no point learning C sharp. If you only need C sharp, you don't need to learn C. Just learn the one you need to, or that you want to. You'll find whichever one you learn, it makes the next one easier to learn because there's a lot of overlap. You're supposed to learn C sharp. Wouldn't it be nice to know C first? It would help you learn C sharp because, again, a lot of the concepts cross over. Learning is better than watching Netflix, unless maybe the Netflix is a learning tutorial thing. So yeah, these are the elementals. So this is like how we parse a string. We're using string from UTF-8 lossy, but we need to know how many. We need to actually collect the bytes, which is what we're doing here. So this has to be a bit string for this to work. Yeah, I gotta call it soon. Data. Okay, getting rid of all the errors here. Okay, so statements doesn't care if it's a bit stream or not, which makes sense. Do I need this at all? Can I get rid of that, or is it gonna? Yeah, it needs to have some name, but we don't care what it is. That's what that says. Okay, here's where it gets interesting. When we're making a new part, we need to actually make a new bit stream. Which makes me think that clone in bitstream, we didn't even specify it. So it should be like subset of self from like an offset and then a length, right? Will generate another bit stream. Can we do that? No, it's going to have a problem because that's not a concrete type. Can we say dyn? Then we have a problem that it's not implemented. Okay, I think I might be going in the wrong direction here. We use dyn when we use trait objects, right? But we don't necessarily want a trait object. Unless instead of using generic, unless instead of making the context and the components generic, they just use a trait object bitstream. Actually, there's another reason why I want to do that, because I might want to mix bitstream types. Yeah, I think, yeah. So I think I do want to use this as a trait object. So that would mean we would return a boxed bitstream. Dyn. So that's a trait object. That means we're returning some object in a box, which means a pointer to the heap. We're returning a pointer to something on the heap that implements the bitstream trait. In Rust, it's a little bit more than a pointer, though. It's the box confers ownership of what's on the heap and constrains the program to like follow the rules and not leak it unless you explicitly say you want to leak the box, and prevents you from sharing it without taking it out and putting it into another type, which lets you do a reference counting. I'm sure someone in chat knows Erlang, but why do you care? How about if you ask why someone in chat knows Erlang? That's like saying, is anyone in chat? It's like, yes, there are people in chat. Okay, then what's the next question? If someone says that they know Erlang, Tristos, what would be the next question? So pretend someone named Awesome Listener 123 said, yes, I know Erlang. What would you then ask Awesome Listener 123? Or would you just say, like, great job, Awesome Listener 123, you know Erlang. You have trouble generating multiple clients for testing with eUnit. Okay. And you're looking for someone in chat to help you? Yeah, that kind of that's leading into a question that like you're asking for help, and that doesn't usually go so well in Twitch chat. Just saying. If it was a quick question, like what's the right class to use for this problem, then maybe that would be better. Yeah, I got to go to work, so this is gonna have to wait for tomorrow. I have to change the this to not be generic on B, but actually have basically this is going to be a boxed dyne bit stream rather than being generic. And bitstream will have that method so that we can make subsets. And that's exactly what a part does. It's going to define a subset of the parent's bitstream for the part. Later, Nightshade, dude. Yeah, time for me to go. Well, I guess we'll raid Tim since he's still going. Bye, MetaMe. Yeah, I'll be back tomorrow, 7 o'clock Pacific, hopefully around that time. Hope you had fun watching this arcane Rust stuff. And if you had fun, whether it was just listening to my voice or this is interesting to you or whatever, if you're co-working, that's fine too, then I hope to see you next time. Okay? Bye.